This is 7.3 continued. Now question 8 asks an awful lot, and I'm not sure I can make it fit on the page, but I'll try. The diagram shows a regular pentagon, there it is, and a regular hexagon. Again, all the vertices are labelled with letters, so remember, vertex is a corner. I've got to calculate the angle EDC. Let me just highlight that for you in blue. EDC, they want that. It's a regular pentagon. Essentially, I need to work that out. Well, the usual thing is to work out the exterior angle and take it away from 360. So the exterior angle is going to be, let's try and get A to fit here, shall we? Here we go, exterior angle. I've got 360 divided by 5, and that comes to something or other. Let's grab my machine quickly. 36 divided by 5, yeah, 72 degrees. So the exterior angle is 72 degrees. Therefore, the interior angle, which they're calling EDC, is going to be 180. Take away the 72 degrees. That leaves me with 108 degrees. What I'm going to do is write it in, because I'm bound to need it later on. So that's 108 degrees. Next one, angle EDI. Lovely, EDI. So it's this part here. In other words, nothing to do with the pentagon. I'm into the hexagon now. So it's the interior angle of a hexagon. So same routine. Exterior angle of a hexagon. 360 over 6 sides, which is an exterior angle of 60. Therefore, the interior angle of EDI is going to be 180, take away the 60, which is 120 degrees. So let's just put 120 there, because I may need that for something else. I've got to work out the obtuse angle CDI, in other words, the leftovers here. Oh look, it makes a complete set of 360. In other words, angles meeting at this point come to 360. And I'm giving my reasons as I speak. So C, I'm going to be, what's it called? It's going to be CDI, the obtuse one. In other words, not this part here. No. Oh, the obtuse. Oh. Yeah, because that's reflex, isn't it? If I went for that one, that would be reflex. That would be 228. No good. The obtuse one, it's not up to 180 yet, so that's all right. What have I got here? The obtuse one's going to be 360. Take away the other two. Try and get it all to fit in here, really. So it's 360. Take away the 108, and I have to take away the 120 as well. So there it is, 132 degrees. Now, next one, I've got to work at angle BAC. Lovely. So they want that one, do they? Right, well that one is the same as that one. This is a regular pentagon. That side is the same length as that side. And look, I've already know how big that is. That is 108 degrees, because I worked it out before. Okay? It's regular, then all these angles. That one, that one, that one, that one, and all of that comes to 180 each. So 108 each, sorry. So how do I work this out? Well, it's an isosceles triangle, and so let's go to yellow now. Angle BAC, I'm going to shade it in yellow, and that's what I'm doing right now. And that's the same as that one, just there. So here I go. What have I got? I've got 180 degrees. If I take away my 108 degrees, I will get 72 degrees left over, and I share this out between these two angles. Therefore, angle BAC is 72 divided by 2, which is 36 degrees apiece. Alright, so all that side is done. Now what about E? Let's hope this all fits. Right, angle CAE. So CAE. In other words, they want this bit right here. Let's just put another little blue bit there. Well, that's not very difficult. If I know this whole angle here, BAE, is 108, I just take away that little bit I just worked out. So let's just do it now. Very, very easy. That's going to be, what's it called now? Angle CAE is going to be 108, the interior angle of a regular pentagon, like that and that, and take away that 36 degree angle there, and that will leave me with, I don't know, 108, take away 36, 72 degrees. Lovely. 72 degrees. F. Calculate angle. Let's just write it in, just in case I've got to use it. So that's 78. I'll tell you what. Oh, sorry, 72. That's 72. That's going to be 72 as well. I bet I'm going to need to use this one. Anyway, I'll put 108 in there and just see how it goes. Right, what have I got here? Calculate angle HIG. Right, they want this one right there. Same again, it's isosceles. I know therefore that's 120 degrees because all the angles in a regular hexagon are 120, and there it is. So that's 120 degrees. So it's easy. I'm going to say 180 take away the 120 is going to be 60 degrees left over to share it between him. And let's shade him in correctly. And him. So that's going to be 60 divided by 2 equals 30. So that was angle HIG. Right, HIG. So that's 30 and that's 30. That's beautiful. Next one, angle DIG. 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 In other words, they want this part here. Very straightforward. All of this is 120. So if I take away this little piece alone, which I know is 30, let me label it in. Come on. That's 30. So let's put it in there. 30 degrees. Incidentally, that's 30 as well. Put it in. Oh, incidentally, that was, I haven't got a clue, I can't remember. What's BAD then? Or BAC? Where's he gone? Yeah, that's 36. And that's 36. I hate not labeling properly. Anyway, all fully cooked. Now, where am I up to now? Angle, this is, get the G to fit there, I hope. So I want angle DIG, DIG. DIG is going to be the 120, take away this 30. Sweet, isn't it? Is going to be 120, the full interior angle, take away this little slice, 30 degrees, and that will give me 90 degrees. Oh, lovely. So that's 90 degrees. Looks like it as well, but never mind. Never go by how it appears, go by the maths. And that's all that little lot done. I think that's quite neat actually. Right, the next one. Question 9 is one of these problem solving things, a bit like question 8. The badge is in the shape of a regular pentagon. Okay, very good. Pentagon, irregular. The letter V is drawing the badge, so there's the V there. What is the size of angle X? Not difficult. Pentagon. Now I'm going to start teaching it from the bottom up again. If it's a 5-sided shape, we've got exterior angle is going to be 360 divided by number of sides, and that will give me 72 degrees. So the interior angle is going to be 180, take away the 72, which is 108 degrees. So guess what? That is 108 degrees. All of that is also 108 degrees. All of these are 108. Yeah, I apologise to the V for cutting across the bottom of his nose. Doesn't matter. It does not matter at all. Okay, if that's 108, I'm going to make use of that in a minute. Now look, it's a regular shape. Therefore, that's an isosceles triangle with these two angles the same. That's an isosceles triangle with these two angles the same. So let's just work out this angle right here. We can then say, I'll try to stay in this corner I reckon. If I say 180, take away 108 is 72 degrees, and I share it out between him and him, the leftovers. So 72 divided by 2 is going to be something or other, 36 degrees. This one is also 36 degrees, and by the same reasoning, it's the same triangle, 108 there, and that's isosceles also, and that's going to be therefore also 36. So x is going to be the full 108 take away 2 lots of 36 degrees. Oops, that's meant to be like a bracket. Didn't work out too well, did it? That's that one. So there we go, 36 and 36, so it's 108 take away 72, and that'll leave me with the x part of the badge. So 108 take away 72, we've got 36 degrees. So there you go, 36 degrees is for that one. Incidentally, look, 336's come up to 108 anyway, so all of these could have been x's. They never told us that, naughty people. Had they done that, I'll just say 108 divided by 3 landed. But I had to work it out, you know, the way that they show me, the way that I had to, not make any assumptions. So x is 36 degrees, and now I'm going to stop and have a cup of tea because I'm really, really tired. Catch you later in the ascent.